Okay, how do we check to see if it's a factor? Factor means it divides into it evenly. You can do long division, but you're better off doing synthetic division. So let's just do quick synthetic division on this. If it's -2, remember you put 2 in the box, and we got -2. Make sure we have all our terms. -2, 4, -4, 9, 0. And then we get -2, -4. That's 0 times 2 is 0. -4 times 2 is -8. I get a 1. All right, is that a factor? No, x minus 2 is not a factor. Okay. Now, what piece of information do I get since this is a 1? This tells me that f of 2, when I plug in 2, you get back 1. All right, so at least we got a point on the graph. Okay, that would be a point on the graph. All right, so that's not a factor. All right, well, here's where we're heading on this part here, section 3.4. I need to make sure rational. What's the difference between rational? What's the difference between irrational? What's the difference between integers? Okay, sometimes I think I assume you've had it, you kind of know, but sometimes I think you get things jumbled together. Basically, this is what we're going to use today. Let me just make sure we're good on this. Integers. And I know this isn't on your guided notes, just pay attention. So you got integers, we got rational numbers, and we got irrational numbers. And this is just the differences. Okay, integers. You can even just list one. Give me an integer. Brooklyn, you got an integer? One's an integer. Tim, you got an integer? 2's an integer. All right. What's the difference between an integer and a rational number? Somebody give me a rational number that's not an integer. Colton?
2.5 is rational, but not an integer.
2.5. Kate?
1/2.
1/2. All right. So integers are positive and negative whole numbers. So I'm going to do this, -, -3, -2, -1, 0, 1, 2, 3. Okay, they're whole numbers. All right, rational numbers include fractions and terminating decimals. Okay, fractions and terminating, like 2.5, 2.45. So these are integers. Okay, so an integer, -3 is also a rational number. Integers plus fractions and terminating. And these are kind of informal. These are not like the exact math definitions, but just give you enough idea. All right, what's the difference between rational number and irrational? Give me an irrational number. How about that? That might be easier. Okay, give me an irrational number. Any ideas here? Austin?
Like 2.3 repeating.
2.3 repeating. Terminating and repeating decimals, because 2.3 repeating is 2 1/3.
Oh yeah. Okay.
So my fault. And I didn't terminating and repeating decimals. So I kind of led you astray. So I'll take the heat on that one. All right, Madison, any ideas? Luke? Pi. Pi is irrational. Okay? Pi is irrational. That's called a transcendental number. But there's more than just pi. Any square root of 2, square root of 5. Okay, square root of 10. Okay? Any of those are irrational. Okay? Though they're non-terminating, non-repeating decimals. So like square root of 2. Never terminates, never repeats. But just kind of think square roots. So you're going to see these words. You're going to say, find the rational roots. Well, rational means it can be a fraction or a whole number. When we get to irrational, it means it's going to have a square root in it. So I just want to make sure you understand those differences. All right, now on here, I'm going to tell you x equals a 2. X equals 2 is a root. It says find all the rational zeros. Well, just find all the zeros. All right, so if x equals 2 is a root, what do? Plug in 2 for the x's, will give you 0, but then how do I find the others? So here's what you want to do. Use synthetic division. Plug in 2 using synthetic division. Okay, do it now. Now, you can use your calculator for computation, but we're not allowed to graph at this point. On your actual chapter test, the first test, first part, there'll be two parts to it. The first will be, again, no graphing calculator. The second will be graphing calculator. All right, does it give us a 0? I hope. So that means I got 1, -4, 1, 6. So that's a 0, 2, -2, -4, -3, and then -6. All right, what do I do from here? Since it equals 0, that means what is a factor? Since f of 2 equals 0, then what's a factor? Remember we talked, this is a factor theorem. Then x minus 2, then x minus 2 is a factor. Yeah. And so what I can do is I can take f of x. That means x minus 2 divides into it evenly. And that's our answer, the remainder here, the depressed polynomial. So f of x now is the same as x minus 2 times x squared minus 2x minus 3. Make sure you understand, if I multiply these together, I get back the original. Since it divides into it evenly, I write it as a multiplication problem. 2 is a root. Well, how do I find the roots to the other 2? If it's a quadratic, you either look at factor or you look to use a quadratic formula. Factor that one. Factor x squared minus 2x minus 3. So f of x equals x minus 2. All right, this is going to be an x. And x, I got to multiply to -3, add the -2. So it's going to be minus 3 plus 1. Okay, that's what we want. We want it in that form. So what are my roots or the zeros? They're synonymous. I call them zeros or I call them roots. So basically you set each of them equal to 0. 0, you get x equals 2. We get x equals 3. And we get x equals -1. So my zeros are, and I'm going to put them in descent or ascending order, -1, 2, 3. Now I want you to understand the connection between the roots and the graph. So we got the graph. They're all multiplicity 1. Multiplicity 1, so the graph goes straight through. Now I know it doesn't say graph it, but I just want to do a quick sketch to make sure we're good with that. So it hits at -1, and it hits at 2, and it hits at 3. End behavior, positive x cubed, so it has to go up from left to right. And so I go through here, and it hits at -1, and it has to come through 2, and it has to go through 3. So we want to make sure we understand the relationship between the zeros and the graph, even though it didn't ask us to graph it. Make sure we know that. All right, I told you x equals 2 is a root. So you plug that in. We got it down to a quadratic. Once we get it down to a quadratic, we want to know where that equals 0. We factored it. All right, that next one there. Find all the rational zeros. Well, it's just kind of giving you a heads up that they're going to be fractions or whole numbers. All right, what don't I give you here? I don't give you a 0. Now it's your job to find one. How do I find one? Okay. Well, you took a number and you use synthetic division until we get a 0. So at this point, we just got to guess. So I want everybody to pick a number. Just do pick one number and do synthetic division. And if you get a 0, then do a cartwheel. And don't use the same number as somebody beside you, because that's just foolish. We don't want to be foolish. Just keep, don't erase it. Just keep whatever you've missed. If it doesn't work, just keep it because we'll use that end result to tell us where it's a point on the graph.
Let's go first try.
Do a cartwheel.
Yeah, do a cartwheel.
Little one.
All right, we got 1 up here.
Cheater.
Oh, you might get some big numbers too. It's all right if you get big numbers. Oops, you get 1, Cameron? What'd you get?
5.
All right, and Tim, what'd you get? You use what?
5.
5. All right, anybody else get 1 that came out to 0? Brooklyn, did yours not work? What'd you try? 3. What'd you come out with in the end?
I'm still subtracting.
Still subtracting. Madison, what'd you try? 1. What'd you come out with at the end? 28. So f of 1 is 28. So it's a positive number. All right. Javen, what'd you try?
Check 4.
4. What'd you end up with?
140.
140. All right, but we got 2 people who tried 5. So here's what you need to do. We want that 0. Go ahead and we'll put 5. And if you didn't do 5, you need to do 5 now. And make sure you get that 0. So 6 times 5 is 30. That gives me -1, -5, -12. -12 times 5 is -16. All right, Tim and Luke, did you guys have a special secret or is it pure luck? Pure luck?
Sure.
Pure luck. All right, so sometimes that works. How can I use this to find the other zeros now? Do I have to use synthetic division or can I just plug in 5 and know it equals 0? Do I have to use synthetic division? Does that help us? Luke Hirschberg, any ideas? No idea?
No idea.
He's like, not sure. Not sure. Do I need to use, Ryan Hammer, do I need to use synthetic division?
No.
What'd you say?
No.
No? Well, okay. I want to disagree with you. Here's why. To find the other roots. To find the other roots. You know 5 is a 0, which means x minus 5 is a factor. I need to get this second piece right here. 6x squared minus x minus 12. I only get that by doing synthetic division. Sorry to put you on the spot there. Gotta set you up for failure. I gotta do that so I get that second polynomial. Because now what do I do with this second polynomial? This is no different than what we did earlier. This is another reason why we spend so much time solving quadratics. You're just solving a quadratic. You can complete the square, you can factor, you can quadratic formula. Now, here's a clue. Since it said find the rational roots, means they're not going to have square roots. So that tells me it factors. So that will factor. So take a second, try to factor it. It's always good practice. As I keep telling you, factoring comes up in multiple sections. So the better you are at it, it makes life easier. It makes life easier. And you can't forget how to do it.
Got it?
No, that's not factoring. That's quadratic formula. Just factor it.
Oh, that's a lot.
It's not a lot of work. It is. I'll give you a hint. It's 3x and 2x that multiply together. Get it? All right. Here's what you did. I know what you did. But tell me, do those two multiply together? Do that? No. So when you do that, then you have to write it as 6x squared plus 8x minus 9x minus 12, and then
Okay.
you do
Okay.
Sam, you got it. What do you got?
X minus 5 times 2x minus 3 times 3x plus 4.
2x minus 3 times 3x plus 4. We'll just work on those two right now, and then we'll come back here. All right. 2x times 4 is 8. Negative 3 times 3 is negative 9. It adds up to negative 1. You get negative 12. Did you do guess and check, or did you do grouping?
I did grouping.
Grouping. All right, when you do grouping, and just a little bit of a reminder, okay, because I know a lot of you do this. So if you're doing grouping, so you take 6 times negative 12, which is negative 72. And you find two numbers that multiply to negative 72 and add to the middle number, which is negative 1. So it's negative 9 and 8. Now, don't forget, when you get those numbers, they're not your answer. You got to do this. You got to do 6x squared minus 9x plus 8x minus 12 equals 0. And then we do this. Hold on. I take out the GCF, which is 3x. And I get 2x minus 3. Take a GCF 4. Make sure you put a plus 4. 2x minus 3. And we get 3x plus 4 times 2x minus 3. Okay, right? So now here's what I got. F of x equals x minus 5 times 3x plus 4 times 2x minus 3. So what are my zeros? Well, I know a lot of you do this in your head, which is fine. Just don't make a careless mistake. You're really setting each of these equal to 0. And so I get 5. I get negative 4/3. And I get 3/2. And so my zeros are negative 4/3, 3/2, and 5. These are what you would have to use for synthetic division. 5 worked, 3/2 works, and negative 4/3 works. Now, I don't think any of you were going to pick negative 4/3 next. I think you were going to pick 3/2. Okay, so you've got to find that first one. Now, we don't like guessing. So we're going to come down a way to figure this out. So we're not just randomly guessing. We're going to whittle it down to a manageable number. We can't get it down to where we can pick it exactly, but we can get it so it's a little bit easier. All right, that should be right there. Yours is spread out. And where it says f of x equals, put down this second part. I couldn't put mine. I'm going to put them side by side here. So f of x equals 6x cubed minus 31x squared minus 7x plus 60. And then we got f of x equals 3x plus 4 times 2x minus 3 times x minus 5. Okay, now you need to see the relationship here. What does 3x times 2x times x multiply to get? 3x times 2x times x. 6 what? X cubed. Okay? So this has to be the case. That whatever that first term is, these in the front, you're with the x, they all have to multiply to give me 6x cubed. Okay, so there's no way that you could have like a 7 here because that's never going to multiply to give us 6. What do the last 3 numbers multiply together to give me? What's 4 times negative 3 times negative 5? 60. Okay, that has to be the case. Now, these two are going to come out in the wash when you FOIL everything out. But the first and the last we're going to figure out. Now, what was our answer to the actual problem? We had x equals what? X equals negative 4/3, right? We had x equals positive 3/2, and we had x equals 5. And think of this 5, let me do this, as 5 over 1. 5 over 1. Well, those numbers on top are the green ones. They are all multiples of which number? Over there on the left. They are all, or not multiples, they're factors of 60. So any number that goes there has to be a factor of 60 because these three have to multiply together to give me 60. Okay, so those -4, -3 right there, those are factors of 60. Well, what are the bottom numbers going to be? They're going to be factors of what? They got to be factors of 6. So those are going to be factors of 6. They got to multiply together to give me 6. You can't have a 7 in there. You can't have a 9. You can't have anything bigger than 6, actually. So those are all factors of 6. And that always has to be the case because if you break it down into a set of binomials, these have to multiply together to give me that first term. And then in the end, these have to multiply together to give me the constant. So this is going to help us whittle down our options. And this actually leads to what we call the rational zeros theorem. Okay, that's there at the bottom. Okay, so all we did here on this case here is just try and build up why the rational zero theorem works. Okay, these first terms here multiply together to give me that first term, and the last term multiplies together to give me the last term. All right, so here's your rational zeros theorem. For a polynomial function with integer coefficients, so integer means whole numbers, right? You can't have fractions, you can't have decimals. If A is a divisor of the coefficient of the term of highest degree, well, that's basically your first term, and B is a divisor of the constant term, then B over A is a possible zero of the function with corresponding possible factor in the form AX minus B. All right, so what that means, let me just go a little bit further. So B over A. So let's do that as 3 over 2. If 3 over 2 is a 0, then what's a factor? What is that going to look like? It's going to look like what? 2A, then 2x minus 3 is a factor. Okay, is a factor. If you just have a constant, so think about 2. If 2 is a 0, we already know this, don't make it harder, then x minus 2 is a factor. We want to deal more with probably the fraction. So if I got -4/5 is a 0, what do you think is a factor? Okay, let's see if any of this is sinking in. If -4/5 is a 0, Tim, what would be a factor?
5x plus 4.
5x plus 4. Good. All right, so we got it. 5x plus 4. Tim's got it. Is a factor. All right, now let's put this all together. So where we're not guessing. All right, find all the rational zeros for the following. So this is on the back. Okay. Now, what did we do the last time? I said just guess. Just pick a number and guess. We don't want to do that. Because we could be there forever. So we're going to use this rational zero theorem to figure this out. All right, now, A's is a divisor of the coefficient of highest degree. So look at your first term. All right, what is its coefficient? It is just a what? It's just a 1. What numbers divide into 1? 1. Now, technically, you got to include plus or minus. So I'm going to say, so my A equals plus or minus 1. B's divide the last term, the constant. These divide the last. All right, what are all the factors of 4? What are all the numbers that go into 4? 1, don't forget 1. 2 and 4. So, and I'm going to put plus or minus for those. So plus or minus 1, plus or minus 2, plus or minus 4. Now, according to the rational zeros theorem, B over A will be a possible zero. Okay, so basically we take all our B's plus or minus 1, plus or minus 2, plus or minus 4, divided by all our a's. Now, since I already used plus or minus up here, I can just use the number 1. Well, since my a is just a 1, what do those all simplify to? Just simplify, they're all divided by 1, so 1 divided by 1 is 1, 2 divided by 1 is 2, and 4 divided by 1 is 4, right? So this simplifies down to plus or minus 1, plus or minus 2, plus or minus 4. Okay, so now how many options are there? How many numbers is that? It's not this 3, you gotta include plus or minus. 6. Those are the numbers we gotta choose from. So instead of just picking randomly, these are our only options. These are my only options. It's either a 1, a 2, or a 4, or a -1, -2, or -4. Now here you still gotta guess. Because how many zeros can this have? It's x cubed. It can have how many? 3. It can have 3 at the most. Can't have any more than that. And so I got 6 options. So one of you pick one of you pick the other. And then use synthetic division. Or pick a different number.
I was gonna do 2.
No.
I should do 2.
Already told.
I want to.
You're great.
Oh, you're so good. He's temporary. I didn't think
Oh, you got one?
Yeah.
And so you both might get a root, and there might be different numbers, which is fine. Okay, and now remember what a root is. A root is where you do synthetic division and you get 0. Really, we only need to find one root. We need to find one root. Okay. All right. You did not get a root. All right, so -2 didn't work. Brooklyn, did you get any in your work? You used -2, and it didn't work? All right, didn't work. Did you get -10 as an answer? 14.
I did it wrong.
Uh-oh. All right, fix that, if you would. Madison, did you get an answer or a root?
No.
No? Awesome. What'd you get?
1.
1. All right, you got 1 as a root. Did we get any other roots? What'd you get?
-4.
-4?
I got -1.
You got -1. All right, there's got to be 3 answers. So if you got something different, I'm going to start with 1. So if you did not use 1 and you got something that didn't work, go ahead and let's do 1. If you got something that didn't work, then just hold on. You can do something. So I got 1. So I got 1, 4, -1, -4. 1, 4, 0. Okay, 1 times 1 is 1. That's 5. That gives me +4. 4 times 1 is 4. Gives me 0. If you found well, here's what I'm going to do. Set this up. So now I got f of x equals, since 1 is a root, that means x minus 1 is a factor. And I get x squared plus 5x plus 4. All right, so if you use a different one, you're going to have a different trinomial there. Just use that. I'm going to tell you now this factors. So whatever you have, factor. And it doesn't matter if somebody found 1 as a root or something different. You got to come up with the same final answers. So this one factors, doesn't have a constant in front. X minus 1, and it factors into x plus 4 times x plus 1. So that means I get my answers are x equals 1, x equals -4, x equals -1. And so now my zeros, or my roots, are -4, -1, and 1. Okay? Well, this is your factored form. X times x times x is x cubed. -1 times 4 times 1 gives me -4. That's how we use that rational zeros theorem. Okay, these are possible zeros. Not all of them will work. But what we did is we whittled it down from an infinite choice to only 6. Okay, that's the best we could do. That's the best we could do. All right, let's take a look at that bottom one there. Now, eventually, it's just going to say find all the zeros. I think that might be what it says for yours. Okay, now I got up there, it says rational error. It shouldn't matter about it. I might just give you a heads up about what you're looking for. But if it just says find all the zeros, they could be anything. All right, now I got an extra degree. I got an extra. So let's all stay on the same page here. Let's stay on the same page. So start with your height. Now this has a 1 in front of here, so this is my A, right? A is plus or minus 1. B's, I need to list all of the factors of 18. Okay, and it's important that you don't miss any. So you can think of pairs or whatever, but 1 and then 2 goes into it, 3 goes into it, 4 does not, 5 does not, 6 does, and then 18. Am I missing anything? Yeah, I'm missing. What am I missing? 9. I'm missing 9. Plus or minus 9, plus or minus 18. All right, we good there? Now, fourth degree adds another little layer that we got to watch for. All right, our possible zeros. Our possible zeros. This is by the rational root theorem. Are B over A. Well, A is a nice number, and it's just a 1. So we divide those by 1, it all comes out to the whole numbers, right? So our possible zeros, I'm just going to list as plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Those are our possible zeros. So how many options do we have? We got 2, 4, 6, 8, 10, 12 options. How many, what's the maximum number of zeros I can have? 4. Yeah, 4 zeros. All right. Everybody try 3, the number 3. Do synthetic division with that. And you're going back, so you got 1, negative 6, negative 7, 54, and negative 18. And it doesn't matter how many terms, we're only concerned with the very first term and the very last term. So I got 1, 3, negative 3, negative 9, negative 16, negative 48. That's 6. 6 times 3 is 18. All right, so we got a 0. So we got a 0, right? That's good. So that means f of x is equal to, so 3 is a 0. What's a root? X, or what's a factor? X minus 3. Now, what is it a factor? What does it multiply by? It multiplies by x cubed minus 3x squared minus 16x plus 6. Now, can I factor that just by looking at it? Can I use the quadratic formula on it? No. We have to do the same procedure where I have to find another 0. Now, you can list the B over A's, but now you're only going to use 1 and 6. I'm not going to actually go through the list. So which ones do I know won't work out of here? 9, does 9 go into 6? No. Does 18 go into 6? So I don't need to worry about these. Well, here's the thing you got to watch. If 3 worked once, it could work again. Some people make the mistake where, oh, I used 3, I'm never going to try it again. And if you don't ever try it again, then you could just get stuck. So we have to do this again. All right, try negative 3, just to save some time. I think that's 1, but I'm not 100% positive. Now which one are you going to plug it into? You've got to plug it into this x cubed minus 3x squared. And some people just continue straight down from here after they found the first one, which is fine. So negative 3, and I use 1, negative 3, negative 16, and 6. So it gives me 1, negative 3, negative 6, positive 18, positive 2, negative 6 equals 0. Okay, so now that's another root. And then if it's a root of the depressed polynomial, it's a root of the original one. So now this becomes x minus 3. If negative 3 works, then x plus 3 works. And now I got x squared minus 6x plus 2. Everybody see where we're at with this one? You have to keep chipping it away until you get it down to a quadratic. Once it's down to a quadratic, what do? We try to factor it, but this one doesn't factor. I'll tell you that now. If it doesn't factor, then what do we have to use? Quadratic formula. You got to use quadratic formula. And you got to use it right here because we got to find the zeros. So x equals negative b plus or minus, that's a b, it's a bad b, square root of b squared minus 4ac all over 2a. X equals, all right, opposite of negative 6 is 6, plus or minus. Square root of b squared, negative 6 squared is 36, positive 36, minus 4 times 1 times 2 over 2 times 1. All right, I got the conjugate pairs theorem. I'm going to need to move this down out of the way. All right, what do we get on the inside? Is it square root of 28?
Yeah.
Okay, now I want to simplify. So that equals 6 plus or minus square root of 28 over 2. And now what is square root of 28? It reduces or simplifies. 2 radical 7. So I got 6 plus or minus 2 radical 7 over 2. All right, you take a look at your coefficients out in front. Are they all divisible by the same number?
Yeah.
All divisible by 2. So you divide them all by 2. So what does this actually become? It becomes 3 plus or minus square root of 7. All right, so here's what we got. My zeros are negative 3, positive 3, and 3 plus square root of 7, 3 minus square root of 7. Yes, you can write it as 3 plus or minus, but I want to make sure you saw there were two different ones. Okay. Now, factored form. Factored form. You always take your root and you do x minus the root. So if my root was 3, we did x minus 3. So right here, f of x equals, if negative 3 is a root, x plus 3 is a factor. If 3 is a root, x minus 3 is a factor. If 3 plus square root of 7 is a root, what's a factor? This is how you write it. You will say x minus 3 plus square root of 7 and do it like that. And then if 3 minus square root of 7 is a root, we'll do it as x minus 3 minus square root of 7. That'll come into play tomorrow. So you can write it in factored form like that. So there's your roots. Now, at the very bottom, it says conjugate pairs theorem. All this means is you cannot have one radical as a root. So if I know a root, if I know 3 plus square root of 7 is a root, I know 3 minus square root of 7 is a root. If I know 2 plus 3 square root of 5 is a root, then 2 minus 3 square root of 5 is a root. If I know negative square root of 7 is a root, positive square root of 7 is a root. They always come in pairs. Can't just have one. Okay, for that. All right, now I want to make sure we get this. So just 4 problems. But they're 4 important ones. Let me see what 13 and 14 said. Page 373. No, we got to solve that.